we're going to look at this idea of equations. Now, equations are different than expressions. Expressions are what we have on one side of an equation. An equation is two expressions equaling each other. So I have an expression equaling an expression, and when that's the case, I have something called an equation. One model, one example of an equation would be maybe 6x plus 16 equals 46. Or 2 times z plus 1 equals 5 times z minus 2. Now, when we introduce variables, there's a solution to the variable that may make this equation true. So one way to get a sense of that is, let's evaluate one of these equations at a specific value. So let's say we want to evaluate this one at 5. Is that a true statement? Well, what we do is we'll take our expression, 6, where there's an x, we'll insert the 5. So I'll make it times of 5 plus 16 equals 46. I'll continue solving both left and right sides as much as they need to be solved. The right side, you guys can do that one. The left side, 6 times 5 is 30 plus 16. 30 plus 16 equals 46. What'd you guys get? You guys got 46. Didn't change at all. And we see that we get an equation that we know to be true. 46 does indeed equal 46. So what that tells me is the value that we chose to begin with, 5, is the value of x that makes that a true statement, a true equation. All right, let's look at another opportunity right here, and let's evaluate it at 7. So you guys can think along with me. Notice that my value, my variable this time is z. Inserted the value everywhere I saw a variable. Now I'll go through and kind of plug along. So it's 2. Do what's inside the parentheses. That becomes 8. On the other side, likewise. 5 times inside the parentheses of 5. Multiply is my operation here. So I have 16 equals 25. Do we know that to be true? Do we know that 16 equals 25? No, it does not. So we know then that 7 is not a solution to this particular equation.